All right, so we've looked at generic types. Let's now take a look at traits in Rust. So traits define functionality for a particular type that you can then share with other types, all right? So what that means is that we can use traits to define shared behavior. We do it in two ways. We do an abstract way, which is good for overriding functions and if you want to leave it open. So if you just want to have functions that you can then pass over, all right? And then there's, of course, the concrete way. And when we do that, we can use traits bounds to specify to a generic type. And then that can have a certain behavior that we can set up concretely. All right. So then what's the point? Well, we use traits often to implement a standard set of actions. So if we want to create like a standard set of methods for multiple structures. So if we have many different structures and we're like, wait a minute, we're going to create these traits and then we're going to implement those for these structures because it just makes sense to do this. And in that sense, they act as interfaces in object-oriented programming. Now, this can all sound a little bit heavy on the conceptual scale. So let's go through what this would look like in code so you can have a better idea. All right. I guess the first thing is, how do you declare a trait? Let's look at that. How do you declare a trait? So we can do this under the main function here. Well, you can use the trait keyword. So let's say we had a trait that's going to give us statistics. So we can say stats. And then there's this method. We haven't built it yet, but let's say there is a method. So we're going to say function character underscore stats. And so since this trait is coming from stats, we're going to use the self keyword here. And we have to use and. It's the only argument. So we could do and self. And that's going to act according to what we want to implement for that argument, as we're going to see. So we have trait stats over here. And if you're unsure of self and, then you should go back. Okay? Now, what about implementing a trait? So that's how you declare a trait. Well, in order to implement a trait, what would the syntax look like? You would want to implement the trait to a structure. So why don't we declare the structure first? If we build out the structure, then it'll make more sense that we're implementing it to the structure. All right? So let's actually build a structure up here. So we have stats. So we're going to build... we don't need this. So I'm just going to say a struct. And let's say the stats for a game. Like we're working on a game, okay? And there's going to be some attributes for this game. So the game has a weapon. And we want it to be a persistent for the whole program. So we're going to make it a string. So we're bringing the and static so that it has a lifetime. So we have to put in the quotation static. And we're going to add another key pair of values. So we got the weapon. And what about a power level? That's pretty good for games. Power level, and we'll pass unsigned value 32. Okay? And that's all we need. So now we have a structure. We've got this game structure. We've got a trait that has the method for character stats. Let's go ahead and actually implement the trait for our structure. How do we do that? So in order to implement, you could say impl stats for game. All right? And now you're implementing this trait of stats into the game. And we're getting access to this function. Technically just the function signature, right? And now with the function signature, we can use it for multiple structures, and we can define what the terms of that function signature is going to be within these different structures. So now we have to pass function character stats and self, and let's define what it's going to do. Now we can say it's going to print, say printing stats, and what do we want? Well, let's say we want the power level and the weapon. Right? And because we're using self with this function, we can actually access that argument, whatever that's going to be, that input, with the weapon and the power level. So in this case, all we need to do is write self.powerLevel for the power level is the first one. And the second one will be self.weapon. All right, let me make this a bit smaller. Okay, and now that we have our trait set up and implementation in the structure, why don't we actually create an instance of our game and see this functionality print for us in action. So we're going to go up into our main code, and we're going to create an instance of the struct game. So we can say let game1 equals game. And let's say for this game, we can set up how we want the power level to be. So I can say the power level in this game is going to be 100, and the weapon is going to be sword of fire. Okay, pretty cool. Now, if we want to actually see what those stats are and print them out, well, we have a trait here where we've created the functionality and we've implemented it into this structure with a specific purpose to have power level, and weapon out. So if I want to get that, if I want to run that for the instance of this game, all I have to do now is bring it in. I can say g1.character_stats and parentheses. Let's call this method into being. All right, so hopefully I didn't make too many mistakes. Let's run this code and see what happens. I'm going to run the code. So I see I have an error already, 42. Okay, so a theme of errors today. This should be a comma. Of course, we're in a struct, and we do not need a semicolon here as well. And I see at 45, we forgot a semicolon, so I'm going to add that here. Also, I don't know why this is down here. The g1.characterStats should be called in the main function, not in Oblivion. So we're going to move that here. Okay, let's move that down here. Let's run the code. We see mismatched types. Power level 100 does not need to be in quotations, so we'll take that out because it's an integer. That makes sense, right? Because power level is U32. And, fingers crossed. Okay, so we got the values 100, string data type, that's from previously, our last video on generic traits. But at the bottom, we see printing stats of power level 100, weapon, sword of fire. And that's what we set up for this instance structure of game. We see the weapon static string here, power level set up properly. We set up traits, and then we implement it. Now, this may seem like a lot for a little bit of code, but this could get quite useful if you're developing many, many different instances of structures in games, and you want to have a core set of traits that you're working on, and those are your traits, and you want to implement them for specific structures, and then keep track in your code. This is where the power of that really comes in, and you can do it concretely or abstractly. And in that sense, they act as interfaces. Interfaces in the sense that you plug them in when necessary to connect the functionality between multiple structures and then instantiate them. So if that's a little bit heady, when you work in professional environments, whether it's in gaming or whatever you're doing in Rust, probably more likely something with finance. That's when these higher ordered concepts, which is why we would put this in a more advanced section, become very useful. Okay. All right, so that's it on generic types and traits. I hope you found this useful. Let's take this information, this knowledge, make sure you feel good about it, and when you're ready, let's move forward and put these puppies into action. All right, I'll see you there.